Hello everyone. In this video we look at the basic idea of what are salts and some of the properties of the salts. Now broadly, if you look at the classification of substances as salts, these are the compounds that are formed by the neutralization reaction between acid and base. Like if we have an acid and base reacting, generally we talk about the arsenous acid, which gives H plus ion, and arsenous base, which gives OH minus ions. So these two will combine to give us salt, and the H plus and OH minus will give us water H2O. If you look at an example, like we have an acid HCl as a solution in water. If it is combining with base, again a solution in water, aqueous solution, then from the acid we have the anion part or negative ion that will be coming in, and from the base we will have the positive ion or the cation. So these two will give us the salt NaCl. So if you look at the salt formed by the acid base neutralization, in that salt the anion part will come from the acid and the cation part will come from the base. Other than that we will get H2O as the other product. So this is how we are going to be forming the salts. And if you look at salts, salts are generally classified as certain families, like we can say chloride salts means all the salts containing chlorine, like we have KCl, NaCl, magnesium chloride, calcium chloride, all of them that contain chlorine. Like we can say sodium salts. So sodium salts will be all the salts containing sodium. We can have sodium chloride, we can have sodium bromide, sodium sulfate, sodium nitrate, and we can have sulfates. Sulfates means all of them that contain sulfate ion. So we'll have sodium sulfate, magnesium sulfate, like that. We can have nitrates, all the salts that contain nitrate ion, NaNO3, MgNO3 twice. Now to write down the formulas of the salts, we must be knowing the valencies of some of the common ions. Like if you look at sulfate ion, the valency is 2 minus. Nitrate ion valency is -1. Carbonate ion valency is -2. Phosphate ion valency is -3. Like this we should ammonium ion NH4 plus. So we must know the valencies of some of the common ions, then we will be able to write down the formula of the salt by using the crisscross method. That's something that we have seen in the 9th standard. So this is how we can classify the salts into respective families. So family is basically a particular type of ion. If it is common, whether it is the cation part or the anion part, we will put them under that particular family. So this is how we generally classify the salts. And if we look at salts, since they are formed by the neutralization, it is not required that all the salts are neutral. Like we can have acidic salts and we can even have basic salts. So we will see how we are going to have acidic salts and how we are going to have basic salts. Now acidic salts and basic salts are formed by the incomplete neutralization. This is the basic understanding. So whether it is an acidic salt or a basic salt, it is formed by the incomplete neutralization. So if you look at a salt as a compound, then as we have seen, the positive metallic ion will be the cation part, and the negative ion will come from the acid part. So we have the negative ion coming from the acid and the positive ion will come from the base. Now if the negative ion which is coming from the acid is capable of giving further H plus ions, then this salt will be called as an acidic salt. If the negative ion that is coming from the acid is further capable of giving H plus ions, then this salt will be called as an acidic salt. If it is not able to give, then it will be called as a normal salt or a neutral salt. Like we will see the examples of what it is. If you see sodium bisulfite or sodium bisulfate, now here sodium bisulfate have Na plus HSO3 minus. Sodium bisulfate has Na plus and HSO4 minus. Similarly, the potassium bisulfite and potassium bisulfate also. So potassium bisulfite has Ka plus and HSO3 minus, and potassium bisulfate will have K plus and HSO4 minus. We can see that the anions, they can still produce H plus ion, which means this anion can dissociate to give H plus and SO3 2 minus. This can dissociate H plus and SO4 2 minus. Same thing, H plus and SO3 2 minus. H plus SO4 2 minus. Because the corresponding acids H2SO3 sulfurous acid and H2SO4, these two are dibasic acids. Means they can produce 2 H plus ions on dissociation, but the salt that is formed by them is not having complete neutralization. It is only releasing 1 H plus, means the anion part will still be able to release the H plus ions, and that makes these salts to be acidic salts. So the salts where the anion part which comes from the acid, if it is able to produce further H plus ions, which happens because of the incomplete neutralization, then such salts are going to be called as the acidic salts. On the other hand, if you have salts formed by the incomplete neutralization of the base part, then we are going to be having the basic salts. So how we are going to get the basic salts is, generally bases are going to contain the hydroxyl radicals. If we have a diacid or a triacid and the OH minus ions are not completely neutralized, then what we see is the remaining salt will still be capable of producing, the cation part of the salt will still be capable of producing OH minus ions, and such a salt is going to be called as an basic salt. So if you look at the examples, basic copper nitrate, you can see CuOH NO3. This can further give OH minus ions. This basic lead nitrate also can further give OH minus ions, because the original metal hydroxide CuOH twice or PbOH twice, they are diacidic bases, means they can produce 2 OH minus ions. But while forming these salts, only one OH minus ion is being neutralized. That is why these salts are capable of giving out one more OH minus ion. So such salts are going to be called as the basic salts. Now, to make it very simple for us to understand, mostly we will talk about this acidic salt and basic salt concept while referring to the salts formed by the acids which can produce H plus ions and bases which can produce OH minus ion. You look at the formula of the salt and you see that there are hydrogens alone, then hydrogens in the anion part basically, then that salt is going to be an acidic salt. If you see the salt and you see the cation part, there are OH groups or hydroxy groups, then this will be capable of producing OH minus, thereby that will be a basic salt. So this is how we look at the salts as acidic salts, basic salts. If the cation part is not having any extra hydroxy groups, if the anion part is not having any extra hydrogens which can come out, then such type of salts will be called as the neutral salts. So this is about the classification of salts into acidic, basic and then neutral. Now we also have a name called as double salts. So double salts are important because they will have certain very salient features which will be useful in particular industrial applications. Like we have more salt, which is FeSO4 NH4 twice SO4 dot 6H2O. So we'll see what this water molecules representation will mean. We will call this as water of crystallization. Similarly, potash alum that is used in even purification of water, K2SO4 Al2SO4 thrice dot 24H2O. So each molecule of this potash alum will be having 24 water molecules. This is called as water of crystallization. So this will be a property of some salts. Now these salts, double salts, are formed by mixing saturated solution. So what is saturated solution? When we are mixing a salt into a particular solvent, so we are mixing our medium, like say we are mixing a salt into water, for example. If we have dissolved the maximum amount of the salt, then that particular solution will be called as an saturated solution. So we take the saturated solutions of two simple salts and mix it and then crystallize. Then we are going to be getting the double salts. Like, the more salt we'll prepare by mixing the saturated solutions of FeSO4 and ammonium sulfate. Ammonium sulfate is NH4 twice SO4. The potash alum we'll get by mixing potassium sulfate and aluminum sulfate. So this is how we are going to be getting the double salts. Then, as we have just talked about, one of the properties of the salts is the water of crystallization, and generally this will happen for double salts, and even some simple salts also will have the property. So what is this water of crystallization? Now these salts that have the water of crystallization, we also call them as hydrated salts. Now these salts, they contain some definite number of water molecules. It is not like the number of water molecules is going to be changing. They contain some definite number of water molecules in the crystals of the salt. So when the salt crystal is being formed, inside the crystal, in the gaps, we will have water molecules embedded, and this is going to be a definite number. Like if you look at the copper sulfate pentahydrate, means for every 1 unit of copper sulfate we have 5 water molecules. That is the ratio in which they will be present. And by the way, this will be called as blue vitriol. And FeSO4 will have 7 water molecules, FeSO4.7H2O. It will be called as, it will be green in color, it will be called as green vitriol. Then we have calcium chloride .6H2O. It is calcium chloride hexahydrate. We will see a lot of these salts will have Na2CO3.10H2O, sodium carbonate decahydrate. This is also commonly called as washing soda. So we have good number of salts that will be having the water of crystallization, and water of crystallization will bring some specific properties, like the washing nature of the washing soda is because of the water of crystallization. If you actually take the washing soda and heat it, then it might completely lose the water molecules, which will be called as the soda ash, and this will not have the properties of Na2CO3.10H2O. So the water of crystallization does bring some properties for the particular salt. Then we have the classification of salts as hygroscopic substances. Hygroscopic is the nature of a salt, where if the salt, when it is exposed to atmosphere, is able to absorb the moisture but do not change the original state after absorption. Like if you see CaO, calcium oxide, or H2SO4, or the silica gel, what they do is they will be able to absorb the moisture from the atmosphere, but they will not change their state after the absorption. Means if they are solids, they would not turn into a liquid solution by dissolving in this water. We will see later that if they change their state after absorbing the water or moisture from the air, we will call that property as deliquescence. So hygroscopic nature means it is the nature of the substances where the substances, when exposed to atmosphere, they absorb the moisture from the air but do not change their state. Means if they are solid, they will just remain as a solid. Examples of the salts that can show the hygroscopic nature is one, calcium oxide. So there are salts that show the hygroscopic nature. If they absorb the moisture from the atmosphere and change their state, generally by dissolving inside the water itself, then that property will be called as deliquescence. We'll talk about it later. Now, whenever we are talking about the salt, we are considering the solution of the salt, particularly in water. But do we think all the salts are, soluble in water? Need not be. So there are some salts which are insoluble. So means those salts will not be dissolving in water, and there will be the soluble salts. Within soluble salts, so we have salts which will be completely soluble and salts that will be soluble only to some extent. We will call it as sparingly soluble salts. Like if you think about sodium chloride, this will be completely soluble. If you look at something like silver chloride, this will be sparingly soluble. If you look at say for example calcium carbonate or magnesium carbonate, they will be insoluble. They will not dissolve in water. Now for the salts which are soluble, we use the concept of solubility. So what is solubility? Generally, if you take a beaker of water and we start dissolving the salt. So initially what we observe is if you put a small amount of salt and stir it, we will see that it will be completely getting dissolved. And we can add some more amount and stir it, we will see that that also will keep getting dissolved. And this state where we see that some more salt we can dissolve in the particular water, we will call this as unsaturated solution. Means some more salt can be dissolved. But if we reach a stage where we have dissolved the maximum amount of salt in the given water, then we will be calling it as a saturated solution. Saturated solution will be representing the maximum amount of the salt we can dissolve, and this is what we will be calling as the solubility. So solubility refers to the maximum amount of salt that can be dissolved in a given amount of water at a particular temperature. This depends upon the temperature. And after reaching the saturation level, it is still possible to dissolve some more extra or additional salt by using alternative methods. Like if we take this beaker and then heat it, then we will see that some more salt can be dissolved, and such a solution will be called as super saturated. But the thing is, the moment we cool it, then we will see that whatever the extra or additional amount that is dissolved, it will start forming the precipitate, or it will start becoming crystals. So this type of solution where we have dissolved extra amount than the saturation level, we will call it as a super saturated solution. So this is how we will look at the solutions into three categories: unsaturated, saturated, and then super saturated. So while we talked about the pH of an acidic and basic solution, we have said pH of acidic solution will be less than 7, and that indicates acidic nature. Of course, we are talking about it the room temperature conditions, and pH of basic solutions will be more than 7. And neutral, we said pH will be equal to 7. So what will be the pH of the salt solutions? Now pH of salt solution need not be equal to 7 at room temperature. So 7 will be referring to the neutral solution. So pH of the salt solution need not be equal to the pH of the neutral. The reason is because we don't have just one type of salts. We have salts categorized into 4 types. We'll discuss about this. The salts which are formed by the combination of strong acid and strong base, like for example, if we have hydrochloric acid and NaOH, strong acid and strong base, they will give NaCl. We have salt formed by strong acid and weak base. HCl is a strong acid. Say for example, ammonium hydroxide is a weak base. We'll have ammonium chloride. We have a salt formed by the weak acid and strong base. Weak acid means we can take acetic acid, CH3COOH. Strong base will be sodium hydroxide. This gives CH3COONA. We call it as sodium acetate. We'll talk about this in the again carbon compound chapter also. This is called as sodium acetate. Then we have salt formed by the weak acid and weak base combination. Weak acid means acetic acid. Weak base means this ammonium hydroxide. Ammonium hydroxide. It will give us CH3COONH4. This is called as ammonium acetate. Now these are the 4 type of salts that we can broadly look at. Salts formed by the strong acid and strong base combination, salts formed by the strong acid and weak base combination, weak acid and strong base, and weak acid and weak base. Now, if you look at a salt, we'll have the cation part of the salt coming from the base, anion part of the salt coming from the acid. So these ions, when we dissolve them in water, because water can give H plus and then OH minus ions. Now these ions coming from the salt, when it is dissolved in water, can react with the water. React with water means either react with the H plus ions of the water or the OH minus ions of the water. And this reaction will be happening for the ion coming from the weaker acid or a weaker base. The ion coming from the strong acid or strong base will not undergo this reaction. This reaction, by the way, is called as hydrolysis. So hydrolysis is basically the reaction of ions of the salt with water. If you look at the NaCl, here the Na plus is coming from strong base, Cl minus is coming from strong acid. So they don't react with either the H plus or OH minus. Means this particular solution will not have any change in terms of H plus or OH minus ions count. Hence it will be neutral. So this is going to be having pH is equal to 7. If you have a strong acid and weak base like NH4 plus ions and Cl minus ions, we see that this is coming from the weak base. So NH4 plus ions will react with OH minus. Means if they react with OH minus, the solution is going to be having extra H plus. Since OH minus is decreasing, the solution is going to have extra H plus. So we'll see that this is going to be an acidic solution. So if it is an acidic solution, means the pH of this has to be less than 7. So if we have the solution of strong acid and weak base salt, then for that pH value will be less than 7, means this will be acidic. If you have weak acid and strong base, like the acid part is the CH3 COO minus and Na plus is the base part. So the CH3 COO minus will react with H plus. Means in solution you will be having extra OH minus ions. So means it will be basic. So pH will be more than 7 in this case. It will be basic. So broadly, if you have the part of the salt which is strong acid, means it will be acidic. Part of the salt strong basic, means it will be basic in nature. Both are coming from strong acid, strong base, means it will be neutral. Now the next thing is if both are coming from the weaker, so weak acid and weak base. Now between the two, one of them will be relatively stronger. See, for example, if acidic part is relatively stronger, then the entire solution is going to be acidic. If the basic part is relatively stronger, then the entire solution is going to be basic. So this is how we look at the pH value of the salt solutions. And sometimes while we are performing the chemical reactions or in some applications, it will be required to maintain the pH to be a constant value or a particular value. It's important for the reactions, including the the reactions where we have biocatalysts being used. They will be able to function optimally at a particular pH value or pH range. So to maintain the pH at a particular range, we will use some substances called as buffer solutions. So this is an idea we can remember. So what is a buffer solution? A buffer solution is a substance that we add to a reaction mixture or to any substance. The buffer will have the ability to maintain the pH of the solution to be constant. So that is what we'll call as a buffer solution. Buffer solutions are important on all those reactions where we have to maintain or keep the pH in a particular range. So this is about the basic idea of salts and their properties. In the next video, we look at the important types of salts, their methods of preparation. So we have sodium hydroxide and sodium carbonate, and some of the other salts which are important in our daily life. We look at how we prepare those salts and what are the properties of the salts, and what are the chemical reactions of those salts and applications of those salts in our daily life. So that we'll continue in the next video.